Alright, welcome back. If you skipped through that last video or missed the first video, the gist of it was that I'm trying to teach just robot programming, not ABB robot programming or FANUC robot programming, but I happen to be using an ABB system here just because it's pretty easy to, it's free to install for a month, and it's pretty easy to show in simulation how everything works and move things around in real time. And this is the only one I'm familiar with at the moment that's quite this good, at least. Not that it doesn't have its bugs and things, but you can do some pretty advanced stuff with this. So this is an offline programming environment, but it's also kind of like an online editor and IDE for your robot. So you can just download it here. Just Google it, download it. I think you have to sign up, but you can get a free trial of it for 30 days. So other than that, I think it's like a couple $1,000s. It's pretty expensive, but if you're buying a robot, I mean, you're looking at the small robots are maybe 25 grand up all the way up to, I don't know, 200. Depends on the option or software options you get, hardware options, all that stuff. So uh, anyway, feel free if you want to follow along, go ahead and grab a copy of this software and move on. Otherwise, you can just follow along here and I'll be doing everything, and hopefully you can get the gist of what I want to show you just with watching my videos without actually having to follow along. Up to you though. So I'm going to create a solution with a standard robot controller. I'm going to go to create here. Oh wait, I want to pick a robot. I'm going to use this ABB 4600 40 kilogram 2.55. This is what I'm kind of used to working with, so I just sort of feel at home, and I know the scale of it and stuff like that. So you can pick any robot in there you want to play with. There's Delta robots and all kinds of crazy stuff in there. The two-arm robots that do this action, and you can play with those, but I want to get the basics down with just a standard serial robot arm and go from there. Okay, so you can see it's starting a virtual controller down here. Hopefully it should ask me here shortly if I want to put a robot into the cell or not. I'm running at kind of a funny resolution here as well, so some stuff may not fit quite right, but it's to make it easier for you guys to see. So this is the older version was orange. Now the newer version, they've switched all the robots to white for some reason. So So I plopped them down in here, and so basically I have a 3D mouse hooked up here, so I can spin this around, which I do highly recommend if you're going to spend a whole lot of time in this program, because the controls are not that intuitive. So uh, anyway, so I've got my robot and nothing for him to do, but we're going to leave him with not a whole lot to do. I mean, I guess I can show you a couple of cool things. I can move him around and come on now. I can move this around by different joints, or I can move it in Cartesian space. But I'm going to get into some of that stuff a little bit later. At the moment, I wanted to just give a tour of the IDE and sort of, you know, where the controller is, what we're doing, stuff like that. So, okay, so I'm going to walk you through a few of these panes and show you sort of what we're doing here. It's kind of painful in this resolution, but what I'm lowering here is the output window. You need to watch that kind of like a hawk to see what's going wrong with the programs, and you know, if your controller has an error or anything like that. So keep an eye on that sort of stuff, and leave this guy open. You will need him, and there's a bunch of other windows that'll pop up later. So you basically have in the simulation mode, you have two sort of conceptual things. You have a station, which is anytime you're looking at these graphics for the most part, or if you're in this layout tab, you're in the station. And so bear with me here on this program. I have to explain some things because it is a little cumbersome to work with. So any changes I make, any points I create, any CAD models, stuff like that is all contained in this station thing. And so if you actually want to run the path, you have to send it over to the virtual controller. So you can see the little controllers running here. So I always kind of just picture him off doing his own thing down there. So you move things between the station that's your visual representation of everything over to controller down here. So that's your actual virtual controller. Okay, so here's the layout tab. Pop some of this stuff open, but essentially you've got your robot here. If you had multiple robots in the actual station, that would be multiple robots and multiple controllers for those robots. They would show up here. So since we're just in the station, the concept of a controller doesn't really exist here. So essentially we just have our links here. So I can drag and jog as long as I select this guy here, joint jog, drag and jog him around, and that's joint 2, joint 3, joint 4, and then let me zoom in here. Let's see where you had joint 5. This would be joint 5, called the wrist typically, or I call it the wrist. And then joint 6 is this rotation on the end. So depending on how you set this up, some of these limits don't actually match the real world, so you need to be a little careful about that. Sometimes something will work in simulation, it won't work on the real robot. So joint limits are one of those things. Like for instance, I can do this, and I don't think the robot can make that position. It might be able to, but you know, stuff like this, you get mechanical interferences. So you need to be careful and be sane a little bit. Obviously, the robot will happily just jam itself right into the floor like this too, which is something that when I was new to industrial robots, and really when I was new to CNC machines, I kind of figured this out, is that the machine doesn't know anything about itself or where it is. And so if you tell it, jab your tool down into its own bed, it's just going to do that. It doesn't know for the most part. So you have to actually program some of that knowledge about the world around this robot into the robot. So back to the IDE, we've got paths and targets here, and all of this is within the station still. So this controller is sort of a placeholder for the virtual controller that we're going to send all this data to. So there's two, I guess technically three ways to input programs into the robot, and one of them, or rather I should say to write programs. One of them is through here, that you actually visually draw paths and targets and stuff, and we're going to do that. But I don't really like the way, once you create a path, the way it works. So I don't use this very often. I write my own code, which I'll get to in a minute. But just know that it's here. So we're going to have to interact with this. We're going to have to interact with the code itself, and we're going to have to transfer data between the virtual controller and the station. So tags I don't use all that often. You can tag paths and things like that. So documents, we don't need that. I'm going to get it out of the way. And so it brings us up to here. This is library stuff. So here's a quick overview of what comes with this software, what robots and stuff. There's the IRB 120. He's just a little tiny guy. You know, you can mount him on a table, a pretty big table, but you know, that's about 2 feet tall by 2 feet long, something like that. And then they just go up from there, and they get real huge palletizing robots, you know, 4-axis palletizing robots, and this big dude I haven't played around with in simulation yet. And then of course a Delta, which is pretty cool. ABB, I think one of the first to do a Delta. And then there's some rotary auxiliary axes, things like that, you know, positioners and stuff. And that's outside of the scope of this, but you can involve these in simulation. It gets pretty rough if you do that. So I suggest getting with somebody who knows how to do that. But and then these are more like placeholders, CAD, just pre-done CAD equipment. So this would be the IRC5 controller for this robot, which is, just to give you an idea, this thing's pretty big. So you can, that's, I think that's the big, actually this is the compact one, so this is the shorter one of the, from the standard. But anyway, you can throw conveyors in here, and then you can throw welding tools and all that good stuff in. And I may actually use some of these, I may make my own, we'll see. So robot system, this is to do with creating a system, which is basically a virtual controller, I think, sort of. The nomenclature is a little odd. You can import geometry, so here I can import STL. It really likes .sat file, ACIS files are the things I've had the best luck with. So if you want to import stuff, go ahead and do that. And you can do some other modeling sort of stuff within the station. So when you're here on this home tab, you're basically in the station. It's weird that they change modally, between the virtual controller and the station with these tabs, but they do. So we'll get into that in a second. Modeling tab is, you know, anything that I would typically do in SolidWorks and import in, so you can create, you know, all this good stuff to mock up your geometry. And a lot of times just a mock-up of the geometry is good enough for tables and things like that. You can model them perfectly if you want to, but I'll show you some tricks for fixing that later on, and when you transition from CAD to the real world, because the CAD in the real world is not usually going to be the same anyway. So it kind of depends what you're getting into, though. So here's some measuring tools that can be useful, and then the same freehand tab state from the previous tab. It's on both these tabs. And we don't need to create tools or mechanism at the moment. So simulation, this is basically only useful if you're going to do the simulation and record it. I'm using external recording software for this, of course, but if you want to make a nice video of whatever your robot's doing, you can do that here. I very rarely use this. Controller. So this is sort of when you break into the actual controller here. So I've switched to this tab, and what it really means is I'm now interacting with this controller. So if I want to back it up, oops, I don't want to click that right now. So if I want to back up, I could do it here. If I want to restart the controller, I can actually just hit restart, and you see this virtual controller doing its thing and restarting. So you can come in and add inputs and outputs. So these will all be virtual, but you can, should be, well, I'm not connected. But you can come in and add inputs and outputs and events and edit configurations and things like that. You can add software options to it if you want. You can actually get to a virtual pendant as well, which here's the controller if you care for that. You can do all this from here. So I thought at one point I had to fiddle with all this stuff, but you really don't. So I just don't mess with that. And operator window I thought was the pendant, but I don't use that either. Because the pendant is cumbersome and I don't care for it. So system would be like editing options on the controller and stuff like that. So it's saying here we've got these certain things on the robot, and if you need to do extra stuff with a real robot, you would do that, but we don't. So so the rapid tab I'll get into a little deeper when we actually have rapid files to work with. But here's where you synchronize back and forth between the station, which is this graphical setup, and then the rapid stuff, which is your programming, like text-based programming for this. All robots will have their own sort of programming language. I think Fanuc can do Carol or TP, which is their teach pendant programming, so you can write them offline and send them. And I don't know, they have a bunch of different stuff. Kuka has their own, Epson has their own. This one's just called Rapid. That's the name of their programming language. It's pretty similar to something like Visual Basic or, you know, Basic for that matter. It's pretty simple stuff, but it does actually, some of them have access to higher level stuff like arrays and objects and string manipulation and stuff like that. And some of them are just bare bones like motion and stuff like that. So I'm very actually happy with Rapid's capabilities. It's got a few limitations I don't care for, but it's been good to me for the most part. So here you can start your program, you can set your run mode to continuous or auto, and mess with files and such. But we'll create most of our files over in the station and send them over here. So checking program, and then, you know, of course, applying changes. Once you change them here on the screen, you've got to send them to the controller, because even though it's local here on their machine, it's pretending it's a real controller. It's just a virtual controller. And for all it knows, it is a real controller. It doesn't really do much different. So you can profile some stuff. And then add-ins, most of the stuff's not super useful to a beginner, at least. Machining tool pack and you know, gearbox heat calculator, weird stuff in there. That was basically it. So there's some options too that sort of hide here. Where are those options? Graphics tools that are hidden, but you pretty much don't need them. The defaults are fine for everything from what I've seen, and you can change a few little options. And somewhere in here there's an actual options. Here we go. and you can get some stuff, change some things, but default's going to work great for us, so don't sweat that too much right now. And that's about it. That's the intro to the IDE. I'm going to start making a very, very simple program on the next episode, and I'll try to keep these to 10 minutes each. So I will see you on the next one.